In this demo, we will look at creating constraints when the table is created up front, and then how to identify those constraints. So then let's log in to the HR schema. Let me drop the table if it already exists. Okay, so it's not there. Student ID is going to be by primary key, but I'll define the constraint later at the bottom as a table level constraint definition. So here are my constraint definitions. I first define the primary key constraint. So the syntax is constraint name. So the constraint name is student ID pk. The constraint type, which is primary key, and then the column to be constrained. The next constraint is a unique key constraint on student's email address. So it's a type unique. I then have a check constraint on the birth date. I want to verify the student's birth dates are legitimate. So I have specified that the birth date is a check constraint on a date column, and I verify the date value itself. Now that I have created a table, I have some explicit constraints: the primary key constraint on student ID, a unique constraint on email address, and remember, email address can also have nulls because it is only a unique, not a primary key. So I have not actually defined email address to be a not null. And I also have a check constraint on birth date to verify that the birth dates are greater than 1st Jan 1970. How do I then go and look into the data dictionary to identify those constraints? So there's two data dictionary views: user constraints and user cons columns. Since the output is going to be very long, let me format the columns first for the query output. These call commands are SQL plus commands. If you're using some other tool, whether it's SQL developer or a third party tool, then you have to find out how to format those column definitions in the output. So that's my column definitions for all the output columns that I'm going to print when I run a query on the data dictionary. Now here's my query. So user cons columns identifies the columns that are constrained, and user constraints identify the actual constraints themselves. These two, table name and constraint name, are the joining columns, and then these are the filter columns, table name. Let me set the line size. So here I can see the output. Email address column has a constraint called student ID email. It's of type U, that is unique, and it has implicitly created an index called student email UK. By default, the index name is the same as the constraint name. There is an extended syntax for the constraint definition where you can actually give a different index name. We're not using that extended syntax. We're just taking the constraint name to drive the index name by it automatically. So student ID PK is a primary constraint, the constraint name and the index name are the same. Then on birth date, I have a constraint called student birth DT, and it's a check constraint. You can see its type is C, and this is the definition of the check constraint: birth date greater than 1st Jan 1970. Last name, there is an implicit constraint which has been defined by Oracle. Implicit constraint name for last name is not null, and student ID is not null. So if you go back and look at the create table statement, we can see student ID was defined as not null and last name was defined as not null. So these two, because we had explicitly defined those column constraints, they are here. If I had not specified student ID not null in my create table, it would have become a not null by virtue of this primary key constraint, but the not null constraint would not have been visible. Then I can see that these are the constraints I have defined: student ID PK, student email UK, and student birth DT, and those constraints appear here: student ID PK, student email UK, and student birth DT. Now what is this position column that I print here? If a constraint creates an index and if the constraint is a composite key, then it might have an index on 2 or more columns. So that is why the position is important. The index student email UK is an index on one column, which is email address. The index student ID PK is an index on one column, which is student ID. If the primary key were a composite key of 2 or more columns, then the second and third columns would appear as position 2 and 3 here. So that is how, for a given create table statement with different types of constraints, primary key, unique key, and check constraint, and explicit not nulls on the columns, I can query the data dictionary views, user cons columns, and user constraints, and identify all the constraints, including the indexes that were created automatically for unique key and primary key.